In this video, I want to take a look at problem 36 in your textbook. It's an even numbered one, so it's not assigned in the homework, but we're given this graph and we're asked to find a formula for it in this form, cosecant of the quantity dx minus c. I'm going to again write that in factored form, b times x minus c2. C2 will correspond to the amount that we've actually shifted things, okay? So I'm going to find b and c2, and then I'll just distribute things so that I can get it into the form asked for. All right, I will mention that in the textbook, when they're giving you the graphs, they actually have drawn part of the next period here. I think that's setting a bad example. They're drawing part of a period instead of starting and ending at an asymptote. Don't follow that example. They're just saying, hey, here's a snapshot of part of a graph. This is the part that fit on the page. And so you see them starting not necessarily at an asymptote in those problems. Okay, so let's take a look. I can see, actually what I'm going to do is I'm going to really quickly just draw a quick version of the non-translated cosecant to remind me of what that looks like. So it's the reciprocal of sine. So it would have, prior to any transformation, it would have asymptotes at 0, pi, and 2 pi, and then the lovely flipped bumps. Okay, fabulous. Now I know that this number b is going to be related to the period. So let's see what the period is. The period is going to be the ending point of 9 pi over 8 minus the starting point of pi over 8. That's going to give me 8 pi over 8, which reduces to pi. So the period is pi, but I know that I can get that by taking the original period of 2 pi and dividing that by b. So if I want to solve for b times pi equals 2 times pi, divide out that pi, and b is going to be 2. Okay, fabulous. So I know that b is 2, and now I want to see how far I've shifted things. One word of caution with the shift. Any value, any x value other than 0 is going to be affected by both the stretching and the shrinking and by the shifting. The only value that's not affected by the stretching and the shrinking, but just the shifting, is when x is 0. So when I'm trying to figure out how far I've shifted things, I always want to look at where 0 on the original graph got moved to. Now in this case, that is my starting asymptote. But in the homework, you're asked to do a similar problem where it's with the secant graph. If you shifted that, you don't want to look at where your starting asymptote gets moved to, because the starting asymptote isn't at 0. It's usually we graph there from negative pi over 2 to 3 pi over 2. So make sure you look at where 0 is. That would be our starting asymptote, the asymptote before the u that opened up. Looks like we've shifted that pi over 8 to the right. And we would accomplish that by simply subtracting pi over 8. So I can say we've got y equals cosecant of 2 times x minus pi over 8. So that's in the factored form. And to get it into the form that the book asked for, I'm going to just distribute that too. So it would be cosecant of 2x minus 2 pi over 8, which will reduce to pi over 4. So essentially my b is 2, my c is pi over 4. All right, excellent.